Yeah, okay. Day 27. Alright. So we're at this point where we can do... Actually, first thing... I think there's... I can do that. I think I figured this out, more or less. Yeah, so wall bound, wall bound 2. We could just... like, we kind of know all of the arrangements for the walls. So, given the bound 1 and the bound 2, we could transform that to left and right or top and bottom pretty easily. It's like, so that it's the same for all of them. And looking at these walls, it's always... So if this is left, then left always gets extended. And if this is top, then, well, actually bottom gets extended. Yeah, so, well, I mean, I guess we can do right, and... It's like, the first point could always be just the point that does not get extended, and it's the second one that gets extended. Or the other way around. As long as it's consistent between the walls, it'll work. So like right and top, I guess, because we're doing collision. We're doing collision with the bottom left, aren't we? Yeah, we're doing collision with the bottom left. So that's why it's like this. And if you're doing collision with the bottom left, then the bottom and the left is the thing that gets extended for the walls. So bound 1. Anyway, so how do we do that? Well, P1, like this point will always have a smaller x coordinate, this point will always have a smaller y coordinate. And the other coordinates is just going to be the same. So I can just do this. So wall bound 1 is min, well, x. Wall bound 1 x, wall bound 2 x, and same with y, and then bound 2 would just be the opposite, so it will be max, like that. Okay. Except that we're modifying them, so all of this is OG, and then V2, wall bound 2, is that but with maxes. And again, it's all OGs. And I think I'm missing that. Alright. Okay, so these are the originals that go in the original order. And those are... And these are, specifically, this is going to be the left and the bottom, except that... Well, this is going to be the left and the bottom... Wait, is it going to be the bottom? So if x is smaller or if y is smaller, and we're bottom up, so yeah, it will be the bottom. Okay. And this is gonna be the right or the top, depending on the wall orientation. Now, what are we using these for? Well, that one's used in one place. This one's used in more than one place. But now this doesn't need to happen this way. So wall extension is like that, and what gets extended is the left or the bottom, right? Wall unit vector collision dimension. And yeah, well, we might have to actually modify. So the extension always happens to this point, and it always happens in the direction of decreasing coordinate. So we need to subtract. We need to subtract from either the x or the y, depending on the orientation. So that's where this dot product comes in. So if you just do wall unit vector dotted with the collision dimensions, then well, unit vector, yeah. Dot product with the collision dimensions, that will kind of be inconsistent, actually, won't it? Because that will be positive, this will be negative. But we need to subtract no matter what. And it kind of works here, right? It's bound. Yeah, we're subtracting here, 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 and here. Wall unit vector wall extension. Alright. Wall unit vector dotted with the collision dimensions. This will be negative. And then we subtract the negative from bound 2. Oh yeah, we actually... Oh yeah, so it becomes positive. Oh yeah. And, or, well, if it's... Yeah, like here it will be positive. Because this is P2. So if it's smaller than 0 and we subtract it, then it becomes positive. Bound 2 minus extension. Interesting. I mean, this does work, but what we need is not that. It's always bound 1. It's always bound 1 that gets extended. Now this can be positive or negative, unless, of course, we do the absolute value. Oh, actually, we can just do the absolute value here, right? Well, wait, we scaled the wall unit vector by that amount. Oh, that's where the flip happens. Yeah, okay. Hold on, maybe then we don't need the absolute value even. Because, like, this will be negative, but then if you scale it by a negative number, it will be positive. This will be positive, you scale it by a positive number, it's still positive. So this will be the actual extension vector will be pointing up in either case. And here, well, I need to draw the unit vectors, I guess. And here, this will be negative. You scale it by a negative number, it will be pointing away from where you extend it. And this, and this will be positive. So scale it by a positive number. Okay. Yeah, so we can always just subtract that change vector. We can always just subtract it from bound 1. Yeah, so before we were subtracting from either bound 2 or bound 1. Now it's always bound 1. I mean, let's see. Okay, so this is fine. Yeah, that's fine. Yeah, that works. Okay, top works. Yeah, right. Yeah, right also seems to, I don't know what happened there exactly. Did they just miss it? Yeah, probably. Okay, that works. Bottom seems to work as well. Yeah. Okay, so that's slight simplification. Simplify collision a little. Okay, now on to the harder part, which is take what we've drawn and make collision out of it. Yeah, so right now I just have the one little rectangle. So if we could just extract collision information out of this, I mean, ultimately that collision information is just gonna look like, actually I might as well change the last part of it. So that, yeah, I'm not doing that. Yeah, instead of specifying collision lines, actually, yeah, instead of specifying collision lines, I should probably specify just the collision like polygon, and and then derive the lines from it. So like just go 1, like 0, 1, 1, 2, 2, 3, 3, 0. Because that's probably what we want to be extracting from assets. There's no reason to repeat every point twice. And in the collision polygon, in this kind of collision polygon, the points need to go from like clockwise. So from y to x, the rotation is clockwise, because p1, p2, and then if you rotate in the xy, that gets you the normal. Yeah, so collision polygon like this is what needs to be extracted, which is just an array of v2s. Temp collision polygon. So right now we just have 1, which is an array of these things. And the level would just be an array of those. Okay, so let's say 100 well, sure, okay, 100 on the x. Start with the top left, I guess. So 100 on the x and like 40 on the y. And then go forward on the x a little bit, so like 110, and still 40 on the y. And then go down, so the x's stay the same, the y's change, so let's say minus 40 and minus 40, except that the order needs to be this. So 100 on the x, 40 on the y, then 110 on the x, 40 on the y, then 110 on the x, minus 40 on the y, 100 on the x, minus 40 on the y. So there we go. Okay, so collision lines go away. Now we're looking at this collision polygon. Alright, so where are we using? Well, we can essentially derive the lines from the polygon. So however many points the polygon has, we are always going to essentially iterate through each point once, because like each point is the start of a line. So yeah, so 4 points in a polygon means there are 4 lines, right? Is that always the case? So this polygon would have 1, 2, 3, 4, 5, 6, 7, 8 points. And 1, 2, 3, 4, 5, 6, 7, 8 lines. Yes, seems to be working. Alright, so collision line index would simply be temp collision polygon, right, like that. And now we just need to derive the collision line. So we just say v2 collision. Well, actually, what is a collision line? P1, P2, huh? Well, okay, I mean, sure. So collision line is this the first, well, temp collision polygon collision line index. So that's the first point, and the second point is just that plus 1. Except that we need to wrap back to 0. Yeah, so that, and of course we also need to draw them. We could just draw the polygon, I guess. But okay, I don't know. I mean, there is already a to-do that says it's temp code. Yeah, it works. C over any other language? Well, maybe. I'm not convinced by anybody's attempts to fix C. Like, I'm not convinced that they're doing that good a job at it right now. But they're also all in beta. So maybe someday they'll figure it out. Yeah, it works. Now I just need to get that from the assets. Well, let's go to the assets. What am I doing with the stages? Nothing. Yeah, nothing. But I am pulling out the infos for the stages. Index, variant, and content. Alright. Okay, so we're sorting the entities because the names need to come in the same order as they are in the enum. We don't really need to do that with the stages. Deduplicating names, yeah, I mean there's going to be only one, presumably. Well, I mean there are variants. Yeah, but they're separate. It's already in the art. So there's essentially one file per stage. Now the point is to somehow iterate through. Well, actually, we could start from the end. It's probably easier, actually. So what's in here? Where is the stage array? Well, it's right now it's just an array of files. There, that's the stage array. It's an array of file infos. Yeah, so what are we generating? We're generating this. And what we want is collision polygons. Well, per stage, I guess. Collision polygons per stage, does that mean... Does that mean what we have is like struct... I mean, collision polygons themselves would just be an array of... Well, an array of collision polygons, like a collision polygon array. Well, actually not array. Collision polygon, all data, you know, with whatever. And then elements. Actually, this is stages, isn't it? Yeah, it is. It's stages. Except that collision polygon itself is an array of... Well, I mean, I could put that into common. Type def struct. Is an array of v2s. Points. Well, I mean, I guess it's points and length. Yeah, 32 is enough. I'm gonna put there. There we go. So it's just a v2 array. v2 array, v2 array, v2 star pointer I64. I mean, it's going to be padded anyway. Just like I have these arrays here, yeah. So really, collision polygon is just a v2 array. So then type def struct collision polygon as v2 array. Yeah, just give a different name to it. Oops. Guess it would be an array of arrays, yeah. Of course, where would those points go is a question, because now we have an array of arrays. Did we ever have an array of arrays anywhere else? No. No, this is just the data itself. This is also the data itself. But here we have, for each stage, there's an array of polygons, and each polygon is an array of points. Yeah, so it has to be an array of arrays. Well, let's see how that works out. Collision polygon array would be collision polygon star pointer I64 length. How am I? Yeah, so we don't really need that first one, do we? It's just like that. Okay, well now this would work, except that where are these things going to point is the question. So each entry in all data is gonna be one of these things, which is a v2 array. So there has to be another array here, essentially, right? v2. So this isn't really all data. This is all data. All data to. I mean, I don't really know what to call it. There. So this is what an array of arrays would look like then. So all the points are in here, then all the polygons are in here. And the actual stages are in here. Yeah, so it's like that, but with an extra level. Yeah, that's not so bad. All data 1, all data 2, and then elements. Okay, there we go. Yeah, we can do that. Again, probably easier to start from the end, where we're writing these things. So asset add array field. Actually, we do have an array of arrays, apparently. Animations are an array of arrays. No, but this is an extra level on top of this array of arrays. Oh yeah, because this is an array, and it consists of pointers that point here. Yeah. But this is an array consists of pointers that point here, and those themselves have pointers that point here. Alright. array of array of array, I guess. And this is gonna be called stages. And now we need to specify, we will have to specify the type. So the way we're doing it here, so this is the type of the data, right? But this is like hierarchical now, so this is collision polygon. Unless, of course, I just literally call it v2rr. Is that actually gonna be better? v2rr. Maybe. I mean, I'll try it. I'll try it. This does seem a little weird, but you know. Because that way, I mean, now we just need to say v2. And that just works out. Array of arrays, okay. State, that's the name of the type. And now we need the actual arrays. So this would be stage array, stages, followed by collision polygons, collision polys, followed by collision points. So that. And now if we just specify what these are, it would be something like v2 collision, well, temp collision points is an array of these things. And well, I mean, we already have some of them in main file. It's just something like this. So temp collision points, that's an array of points. Now v2r temp collision polys. There's, well, I'm just gonna put one of these here, which is gonna point here. Collision point, it would be this. An array count. Yeah. Okay, so this will just point it there, and it will just take all the points. Is there no len in v2r? No, there is. I just didn't specify it correctly. these question marks causing errors. That's fine now. At least this is correct. Okay. Now v2 v2 array of arrays. Wait, this. Okay, so this is the points. So the points are just v2s. Polygons are arrays of v2s. So yeah, that makes sense. But an array of polygons is a stage. An array of polygons is a stage, but they also all fit in. Yeah. Anyway, so alright. But they also all have storage. Array count. Alright, and now v2 r temp stages. Stages are an array, like it's a set of collision polygons. So there's only one stage that only has the one polygon, so it's just this. Poly's length. Temp stages. Okay, so stages are actually v2 star. Does that make sense? Oh, it does, because it is an array. Array of arrays. Oh my god. Alright. Pointer, oh god. I64 length. Stages. Temp stages, array count, temp stages. There we go. What's this? Expected 10 arguments. Well, this function doesn't exist. Why did you expect 10 arguments specifically? I don't get it. Alright, so now let's just specify that function. Asset add array. Yeah. Asset add array of arrays. Okay, well, it's something like that. Except that there is an extra level there now. Alright. R of R of R. Name type. Then array pointer, array element size. Yeah, this is gonna break this up. Okay, there we go. So array pointer, array element size, array element count, all data pointer. Except that we have two of these now. So this is array. That's like the topmost. This is like mid there you go, mid data pointer, mid data element size, mid data element count. And this is all data. So this would be the v2s. Alright, and then we'll define one of these, which takes arena data be name data type array and data. No, data type is just a string, so that's the first four. So this would be an array, then mid array, and then data. And it would call this function. Okay, can we break it up? It would call this function with the arena, the data binary builder. Then we'll stringify the name, we'll stringify the data type, and there we go. Okay, so we have array pointer size of whatever, yeah, that's fine, and there's just another set of these. This is mid array. Pointer size length. Okay. I guess this seems to be in a state where it would compile. Stages, collision polys, collision points. Yeah. Okay, so the function doesn't do anything, but at least it would compile. Alright, what does it do? So, well, we do need this begin struct, add array field, end struct. Like at the end of the day, that is what needs to happen. And then we also need to do this pointer fixing. Well, begin struct, end struct. Yeah, of course, pointer fixing is gonna have to be a little different for this specifically. For now, I just want to write something. I want to write something out. Okay. Yeah, unused variables, whatever. Okay, so there is a struct of stages. So we got something going. Okay, yeah, now it's compiling. It's an empty struct. I thought those weren't allowed, but I guess they are now. That's fine. Alright. So first we write out, like what are we doing here? Oh, first we write out like the topmost data to stay consistent. And actually we can just do that, can't we? So this would be, yeah, this would be all data. So this is the points in this case. Lit data type, all data pointer, all data element size, all data element count. Okay, I think that just works. Yeah, so it is an array of points, so that's fine. Next one is that mid array. Mid data, data type, So instead of all data, this is now mid data. Which is an array of v2s, and there's only one entry in that. So that's correct. That is what I specified. And then the last thing is the actual elements. So that would be outer pointer. So that. Okay, so stages, elements. So these are the stages. It's an array of 1, and that entry is an array of arrays of v2s. Yeah. Okay, now we're just compiling with nodes. Okay, so this will still not really work though, because those are like real pointers that point to data that existed in the build program. So that needs to be fixed up. In a way that's similar to what's happening here. But it's not just the elements that are being fixed up, it's also the mid data that's being fixed up. So we could just parameterize that. Like we're already supplying one name, which is, I mean, that's the loop that's being generated, right? A data, animations, shaders, and then we also have stages in here, but there's going to be 2 loops for those. And, well, elements, I mean, these names are consistent. There's elements point to all data, but only in the single of the array. Data, count, name, and also like array level, array hierarchy, size. I32 array hierarchy depth, I guess. So in this case it's a, well, it depends on how you define it, I guess. Let's just say it's 2 for the normal case and like 3 for the other case. But then, well, you would still need to generate this loop just with different name. Maybe it's actually better to just specify the name. So this name would be the like our name. This would be L name. Well, yeah, and this would be element name. So instead of being just dot elements, well, actually, yeah, element name and like parent name, L parent name. Yeah, just with these ones. Okay, so all data. So that's the count. Okay, so instead of being dot elements, this is now element name. Index fixed pointer equals all data. Okay, so it's dot all data, but no, it's actually let L parent name plus the value, essentially. Yeah, plus the value of the pointer. I mean, can't we just do plus equals? I think we can. Like, we don't really need to repeat this. Well, actually, no, we can't, because we need to cast it. Yeah. Element parent name. Then again, that's the array name, and this is element name. Array name, element name. Array name, element name. Then array name again. Let's just remove these. Then it's array name again. So it's array name, element name, array name, parent name. Yeah, array name, parent name. So array name, parent name. Then it's array name again. And then it's element name again. Oh. Okay, so it's that. Alright. So add pointer fix loop. Fix element name, pointer fix element name. Well, actually, so this is not element name, this is array name. Then L name and pointer fix L parent name. I mean, at this point we might as well just pass pointer fix in there. I mean, this doesn't really matter. It's the same anyway. L parent name, L name, array name. Yeah, so just add those two. Element name, okay, well, so this is array name, element name, and L parent name. Like that. Alright. Pointer fix name. All data, that's the element parent name. Element is the element name, and this is the element parent name. So that's elements and all data. All right, what's the issue here? Parent name. Yeah. Let's see. Okay, that does compile. What are we generating? We're generating the same code. Okay, good. So I got the string formatting correctly. So now we just need two of those pointer fix loops here. That's like, okay, elements point to mid data, actually. And and then mid data points to all data and this is mid data element count. So something like this. Let's see, what does that generate? 2 more loops, looks like. Stages elements index. Pointer is mid data plus whatever the pointer is, which is just an index at this point. Yeah, so that seems correct. Now we just need to do this. Make pointers and array elements be offsets from the base of all data. Yeah, so that now needs to be pulled out. Static void convert footers to indices. Yeah. So that needs to be up top here. And apparently we want the count, the size, the size, the pointer, and then the parent. All data pointer and all data element size. Convert pointers to indices. So now we can just call this, presumably, array pointer, array element size, array element count, all data pointer, that's the data for this array, so all, well, in this case, all data pointer, and all data element size. It's passed in like that. Okay, so if this runs, then, yeah, it runs, then that function is doing what it's supposed to be doing. So now, we just do 2 of these, where it's array element count, except that now it's not all data, this is mid data. And this is not an array pointer, this is actually mid data. So mid data, mid data, mid data, and then all data, all data. So mid data goes to all data. Okay. Well, I mean, we could just, if this doesn't work correctly, it's just gonna crash. So we can see that immediately. So now we should be able to pull out, pull this out from assets essentially. So this temp collision polygon, we don't actually need it. Well, I mean, we're gonna have to store what stage we are on. Get collision polygons from the correct stage. So right now it's going to be the first stage. So game, assets, stages, elements, 0. So that's the stage. Which is an v2rr. Stage collision polygons. And we should iterate through all the polygons, but right now let's just do the first one. v2rr collision polygon is stage collision polygons pointer 0. To do, go through all the polygons. What do I already have a collision polygon? Let's start with this. Oh yeah, it's a v2 array, not array of arrays. So that is our collision polygon that we pulled out from the stage. And of course we can't really do array count anymore. This has to be length here. And this has to be pointer. Pointer. Length, like that. Okay, do we have any errors here? Yeah, okay, so this needs to be changed in the same way. Okay, well, I mean, I'm gonna have to repeat that here. I guess that to do covers it. Yeah, so instead of array count, it's length. Nah. And this is pointer. Okay, so if this crashes, then we're not working. It doesn't crash though, so okay, we are working. Alright. Let's see, so now we should be able to change these stamps here and see it move around, presumably. Yeah, so collision, well, our collision it assumes straight lines, but not the whole thing, but a part of it assumes straight lines. So yeah, these have to be straight lines. But I mean, I suppose we could change the collision detection routine to not assume straight lines. Yeah, right. But the art, yeah, the art should probably not, yeah, there we go. Okay, so I'm just gonna put it to do here. Get from art. And let's see, we can commit what we have. Add array of array of arrays. Yeah, that works. Arrays, yeah, more arrays generated. Yeah, that works. Yeah, this is now not relevant anymore because we are kind of pulling it out from the art. Yeah, this is temp stuff. Oops, what did I just do there? No. Are we running? We are. Start pulling collision from art. Okay, I don't feel like doing anything else today, so this is gonna be it. Thanks everyone.